All right, we are done with Unit 5. We're moving into Unit 6. Day 1 here in Unit 6 of other functions, we're going to start talking about absolute value functions. So if we remember what the absolute value is, it's measuring the distance any number is from 0. So because it's distance, it always outputs a positive value. Okay, so the outputs from a absolute value are always positive. So for example, the absolute value of -7 would be 7, the absolute value of 6 is 6, the absolute value of 0 is 0, right? Because those are how many units away the numbers inside the absolute value signs are from 0. So now when we solve absolute value equations, what we see here is, let's take a look at part A. What could we plug in for x to make this equation true? Well, obviously 6, right? Because the absolute value of 6 would be 6. But we know there's another option we could plug in, because we could, just like in part A of the previous problem, we could put -6 in there. And so what we're going to see here is that to solve these equations, we're going to first get the absolute value signs by themselves, and then what's inside the absolute value sign we set equal to the other side of the equation and the negative, the negated side of that equation. Okay, so here's an example of just like, we could just figure this out, right? Plug -6 in there, plug 6 in there, right? For something like this though, so we get the absolute value by itself, it's already by itself, and so we take what's inside, x minus 5, and we set it equal to basically positive and negative whatever's on the other side. So positive 4, but also x minus 5 can equal -4, and then we solve both of these equations. So in this one I would add 5 to both sides, and I would get x equals 9, and over here I'd add 5 and I'd get x equals 1. And we can see that if we plug 9 into this equation, 9 minus 5, 4, and the absolute value of 4 is 4. And if I plug 1 in, 1 minus 5 is -4, and the absolute value of -4 is 4. And so that's the steps to solving these equations. So here's an example where the absolute value is not by itself yet. So the first step we would have to do is divide by 2. Okay, so remember that first step is just get those absolute value bars by itself. So now that's going to leave us with the absolute value of x plus 3 is equal to -5. So now from here we could do what we just did in part B. However, we are not going to do that, because what we see here is that the absolute value, once we've gotten the absolute value bars by itself, it's saying that it's going to equal a negative number. But we know from the definition of an absolute value and the work we've just done before, it's always going to output a positive value. So the absolute value of something cannot be -5. And so for this, we would have no solution. Okay, because we can't output a negative number. So if you get the absolute value by itself and the other side is negative, then that's no solution. Number 2, determine at least 5 solutions for each 2-variable equation. So here we're just talking about like solving equations, getting x by itself. Now we're going to start talking about the actual function itself. So coordinate points, right? So if I'm talking about x, y coordinate points, what are some examples we can use? Well, if x were 1, right? If x were 1, then we would be plugging in 1 for x, and we'd be outputting, well, what's the absolute value of 1? Just 1, right? And you can just list as many examples here as you want. So if I input -3 in for x, the absolute value of -3 would give me a y value of 3. Okay, and so on. Okay, so you guys can come up with 3 more there. They said come up with 5. For part B, absolute value of x minus 5. So let's use the same x values I just used. So if I do an x value of 1, well, I plug 1 in, 1 minus 5, negative 4. And so the absolute value of negative 4 would be positive 4. Okay? And then if I use negative 3 as my x, plug negative 3 in, negative 3 minus 5 is negative 8. Absolute value of negative 8 is positive 8. So the y value would be positive 8, right? What we would output. And so that's essentially what the absolute value function is. It just outputs the absolute value of something. So you guys can come up with 3 more examples there. All right, so now let's consider really the same function as what we just looked at part A, right? Y equals absolute value of x. Well, here we're just using function notation. Remember, f of x equals absolute value of x is the same as y equals. So explain the meaning of this function in our own words. So how would we explain the meaning of this? Well, the function measures the distance any number x is from 0. Right? So we can plug any number in for x, and we will output the distance that number is from 0. So state the domain and range. Well, domain is our input. So what did I just say? I said we could input any number in, right? So the domain is going to be any real number, or all real numbers, right? So I'd say all real numbers. I could say from negative infinity to infinity, okay? However I want to write that domain. The range. Well, what type of numbers are we outputting? We're outputting all positive values, right? Positive values, or it can be 0 as well, right? So the range of this function, the output, f of x, or the y values, if we want to think of it that way, all of these values have to be greater than or equal to 0. Okay, so the range of the function is going to be all values greater than or equal to 0. So let's create a table of values for this function. I'm going to start in some negative values. It looks like we're going to be graphing over here, so let's do like negative 10, negative 5, and 0. Let's throw a 2 in there. There's a lot more options here. 3, 5, 7, 10. Okay, I could have balanced that a little bit better, but oh well. The y values are the outputs. So what's the absolute value of these inputs? The absolute value of negative 10 is 10. Absolute value of negative 5 is 5. 0, 2, 3, right? It's just all positive values, or 0. And then let's go ahead and plot these points, create the graph. So negative 10, 10, negative 5, 5, 0, 0, 2, 2, 3, 3, 5, 5, 7, 7, and 10, 10. And so what we get is sort of this straight line going down here, and then a straight line going up here. And that does continue on forever. Those are supposed to be arrows. And so there's our function, right? So that's our function, the absolute value function. It's the base absolute value function. It's like the standard one, right? Absolute value of just x. And now what we're going to do is we're going to take a look at what if we took two different functions, right? So what if I said that my first function here, so this is what I'm talking about here, right here. My first function is equal to negative x, but only when x is less than 0. So here's where x is 0, right? It's right there on the y-axis. So we're talking about when we're left, when we're less than that, on the left side. we're going to plot this function negative x. What does that look like? Well, that's a linear function. It's decreasing, has a slope of -1, right? So it has a y-intercept of 0, right? So it would intercept there, and it's got a slope of 0, and so it's just this line, essentially, that's going down 1, right 1, the whole time. And as we get closer and closer and closer to 0, we're not including 0, so we're just getting as close to 0 as we possibly can. Okay, we're not actually including it on this left side for purposes, right? Now, what if I say, okay, well, now let's graph another function. Let's graph, our next function is just x. And this is, we're going to graph for when x is greater than or equal to 0. So when x is greater than or equal to 0, we're going to graph the regular function x. Well, what does that look like? Well, that would have a y-intercept of 0. And this one we have that included, right? Greater than or equal to 0. So we're going to go ahead and plot that point, and that kind of connects the two lines. And then that's going to be a slope of +1, so that's up 1, right 1. And we get this idea here, where, okay, now we've just taken two functions, kind of graph them in two separate areas, and we get the same function as the absolute value of x. Okay, putting two of them together. And that's essentially what a piecewise function is. And so that's the absolute value function is a example of a piecewise function. So we can write the absolute value function like this, which is the way we always do it, pretty much. Or we can write it in a standard piecewise way. And so we're going to show you that because we're going to start talking about piecewise functions. So here is how we write piecewise functions. So just like we did in part G, we kind of broke it up into two different rules, and then we said when to use each rule. And so with a piecewise function, this area, this spot right here, this is showing us the rules that we can use. Okay? Here, this is telling us when to use which rule. Right? So essentially, let's see if we can use this function. What is f of 5 according to this piecewise function? Well, first we have to check this side. When do we use which rule? Because I don't know which rule to use yet. So first of all, I look at x. X is 5. That's a 5. Is x less than 0, or is it greater than or equal to 0? Well, since it's 5, it's greater than or equal to 0. And so we just have to plug it into this rule. So I plug 5 into this rule, and if I plug 5 into just x, right, I get 5. Is the absolute value of 5 5? Yeah, that's how this absolute value piecewise function works. If we choose something like f of -7, which rule do we use? Well, is x less than 0, or is it greater than or equal to 0? Well, it's -7, so that's less than 0. So we're going to plug it into this function, right? So when I plug that in, I'm going to show you what it looks like. It's plugging into -x, right? So negative, and here's where I'm plugging in my value. Okay, and so essentially what we get is f of -7 equals 7. And is the absolute value of -7 7? Yes. Okay. So that's how we use piecewise functions. Okay. The absolute value is an example of a piecewise function. We will do more work on piecewise functions in the next video. This, though, we're going to focus on the absolute value. Okay, so the calculator can do the absolute value for us. If we go to the math button, and then we go to number, the first option, ABS, that stands for absolute value. Now on your calculator, you're going to see either like this. You're going to see the absolute value bars and you can start typing inside, or you're going to see this. If you see this, you just have to remember that these parentheses kind of stand for the absolute value bars. Okay, and so you would type whatever you want to type in there, and then you would close the absolute value bar. So like the parentheses would be the absolute value bars, if that's what you see. If you don't, then you're going to see something where you can just type something that looks like that. So let's go ahead and go to our calculator. And since we're going to graph, we want to start at y equals, because we want the absolute value to appear here. So we're going to press math, and then we're going to go over to number, first option ABS, absolute value. So mine comes up with the absolute value bars, and I'm ready to type something in between. And we are typing in x minus 4. And because we're graphing this, I like to go to my table and see the points, and I like to plot the nice points. So just like quadratics, it is nice to find the x-intercepts, right? So that might be one of the first points I like to plot, the 4, 0. And then I can start plotting all these points that are around it. And what we can see here is we're going to get all of these points. And just like the standard absolute value, the one we graphed on the previous page, it's going to get this sort of V shape, which is a nice way to kind of remember what an absolute value function looks like, as I missed those points at the end there. Because absolute value looks like a V, right? It's a nice way to remember. Where is the function increasing? Remember, you always read a graph left to right. So if I start on the leftmost part of the graph and I just kind of continue tracing the graph, am I increasing or decreasing? I'm decreasing. And at this point, now it starts to increase. So this function is going to be increasing after we've reached a value, after we've reached which x value. So that is an x value of 4. So this is increasing when x is greater than 4. Okay, technically it's not increasing at 4 because it's like right there at the middle. It's at the end of the decreasing, it's at the very beginning of the increasing. It's neither one really. Where's the function decreasing? Well, we just said that we were starting decreasing, right? So from negative infinity all the way up to 4. Or we could just say that it's when x is less than 4, right? Okay, let's graph this one. So here we have, look at the difference there, right? X minus 4, the whole thing is inside the absolute value sign or bars. And here we have the absolute value of x, and then minus 4 is on the outside. And this might sound a little familiar to you, like doing things inside the function versus outside the function. Going back to transformations, we're going to kind of review some transformations later on in this unit. So if I go back to y equals, I'm just going to go ahead and clear that out. I want to type in this function. So math over to number, absolute value, and it's absolute value of x. Now to get out of the bars, I just have to go to the right. Right? I arrow to the right. Now I'm outside of the absolute value sign. And if you have the parentheses, you just have to close the parenthesis. So you close the absolute value bar, and then you press minus 4. Now I can go to the table, and I can see all these values. I can go ahead and start plotting them. So this one, 4, 0, that's correct, yeah. 4, 0 is also an x-intercept. Okay, but when I look at the points that are around it, I'm getting 5, 1, 3, -1. So I'm doing this and this. And in fact, if I continue plotting all these points that I see, and I can continue scrolling up and down and all of these things, I'm going to start plotting these points, and I'm going to get something that looks like this. And then I'll just go ahead and try and create these lines. And I get this as my function. So state the domain for this function. What x values can we use here? Just like any other absolute value function, I can plug in any real numbers. So this would be all real numbers. Okay, you can say from -infinity to infinity if you want. State the range. Okay, the range. We can do this graphically, the bottom to the top of the graph. The very bottom of the graph, what's my y value? It's -4. And then, are we including this -4 point? Yes, we are, so put the equal sign in there. And we're talking about our output values, our y values, so we could put a y in the middle here, or we could use our function notation. And then we go to the very top, and at the very top I see arrows, so that's going off to infinity, and we can't include infinity because we can't get there, and so there will be our range. Okay, or we can kind of simplify it like we did up here, and we can say the range, since we're talking about the output values, we'd be using f of x. And so what are the output values? Well, they're all greater than or equal to -4. Right? That's kind of an easier way to deal with infinite ranges and domains and things. So here's some relevant vocabulary talking about piecewise functions and absolute value functions. Next page would be practice, so I would ask you to go ahead and pause this video, try to work through these problems. In number 1, we're graphing an absolute value function on a specific interval, so we're not actually plotting all the points on our calculator. We're only plotting the points from -6 to 2 and everything in between it. Okay, so I would say go ahead and try that, plug it in your calculator, plot the points only from -6 to 2 on the x, and see if you can answer those questions. Okay, and I'll go over them. So I will go right to my calculator. Y equals, it's the absolute value of x plus 3. And looking at the table, we want to go from -6 to +2. So there we go, -6 to +2. And then I'm going to fill out the table. So it looks like 3, and then goes to 2, 1, 0, 1, 2, 3, 4, 5. Let me make sure I did that correct. Yeah, I just copied down those values from the table. And now I'm going to go ahead and plot these. Oh, I should probably do part A too. Evaluate f of -5 and f of 2 without a calculator. Whoops, let's pretend I didn't do the calculator part first. So f of -5. F of -5 equals the absolute value of -5 plus 3. Right? So I just plug -5 in. Well, what's -5 plus 3? That's negative 2. So what's the absolute value of negative 2? Positive 2. F of 2 means plug 2 in. So the absolute value of 2 plus 3. What's 2 plus 3? 5. Absolute value 5 is 5. Okay. Now we can double check on the calculator and see that those are indeed the points that we just got, right? Negative 5, comma 2, and 2, comma 5. And now we can go ahead and plot all of these. Let's see. I'm going to go to negative 6 and positive 3. And then negative 5, 2. Negative 4, 1. Negative 3, 0. And we get this V shape again, because it is an absolute value function. Now, because I'm only graphing from negative 6 to 2, I'm stopping there. I'm not going to continue this on forever. I'm not going to put arrows. I'm just going to create that, because that's all there is to it, right? It's just graphing from there. So over which of the following intervals is f of x always increasing? Always increasing. So if I just check the options from negative 6, so when x is negative 6 to negative 3, am I increasing there? No, that's decreasing. Option 2, negative 2, so when x is negative 2 to positive 1. Am I always increasing from negative 2 to positive 1? Yes, so that looks like it's the answer. Okay, if we check the rest of them, from negative 4 to 0, part of that interval is increasing, but it's not always increasing because of this part. Okay, and same with this, negative 5 to 2, no good. State the range of f of x on this domain interval. So on the current interval we've graphed, what is the range? Well, bottom to top, right? So the very bottom, what's the y value? That's a y value of 0. And is it included? Yeah, I don't see any arrows. I don't see any open circles to say that it's not included. So that's included. And we're talking about our output values, our y values, or our f of x values. And then what's the very top of this function? This is in the top. The top would be all the way over here. And that's a y value of 5. 1, 2, 3, 4, 5. Yep. And is it included? Yes. There's no arrow. There's no open circle. So we're going from 0 to 5, essentially, is our y values, or our output values of the function. So next, we would be graphing these functions for practice. Those would be the last things we do. So if we go to our calculator and plug those in, we get, what is that, 3x minus 7. We look at the table, we are seeing much larger numbers in this one. So I'm just going to plot the points that I can on the scale that I'm given. So negative 1, 10. So negative 1, do we have does 10 fit here? 2, 4, 6, 8, 10. Yeah, 10 is the top. So there's that, and then 0, 7. And it looks like we get something that looks a little bit like this. So when I plug these values in, I start plotting the points, 1, 4, 2, 1. Next would be 3, comma 2. And then 4, comma 5, and so on. What we get is these points, and to connect them, what's going to happen is we don't actually see the x-intercept here. However, there is an x-intercept. It's at 7/3, right? If I plug 7/3 in, I'm going to get a 0. I could just set it equal to 0 and solve. So I kind of have to estimate where that would be. But remember that it's going to be a V shape. Ooh, that was pretty bad. This is a strange angle. So I'm going to I'm going to try to draw a straight line, and it hits the x-axis at that sort of 7/3 area, and then turns and completes the V shape. Okay, so you might not have known how to kind of graph that, the bottom of that, but don't forget on your calculator, plotting the points is the first step. The next step is you can look at the graph and see what it looks like, and make sure your graph follows that same sort of pattern. It's a V shape, and it hits the x-axis 1/3 of the way after 2. Okay, there's that 7/3. Next function, absolute value of 3x and then minus 7. So I will just change that to be correct. All right, so now the minus 7 is on the outside. I will look at the table, and these points I can plot. So -5, 8, 2, 3, 4, 5, and up to 8, right about there. And the next one is -4, 5. -3, 2. -2, -1. 1, -4. 2, -1. I just skipped a bunch of them. 0, -7, sorry. Then 1, -4. And we see this V shape. So I plot those points. I try to make a straight line. Kind of messed up at the end. That's pretty bad. Hopefully yours came out a lot better. There we go. Okay. So remember absolute value. When we take the absolute value of something, whatever's inside that, we will always output a positive value. What we've been noticing is sometimes we end up with negative y values, but that's because we are doing things outside of those absolute value bars, right? So we could certainly output all positive values here in this part, but then if I subtract 7 from those, well then yeah, I'm gonna kind of shift that whole graph down 7 units, and that's that idea of anything on the outside is going to shift vertically, right, up or down. So if I were adding 7, I'd be shifting that up, okay? And anything on the inside is going to be shifting horizontally, right? So that's why we're still on the V part, the x-intercept still right there on the x-axis. We're just kind of shifting left and right. And then there's this idea of the multiplier as well, making things wider and narrower. And we'll go back and review all of that stuff as well. So there's absolute value functions. I will be back with another video on piecewise functions, and until then I will see you later.